Okay, so in this video we're going to look at combination circuits. Combination circuits are circuits that have both series and parallel resistors in there. So we're not really going to learn anything new, any new equations or anything, but we're going to learn how we should apply them when we have more than one circuit, or more than one type of circuit, all in one. All right. Oops, went the wrong way. I went too far. All right. So let's pretend that each resistor has a resistance of 10. We're just going to give them all one number. They could be different numbers. They could be the same number. We're going to use the same process. We're going to calculate the resistance of the entire circuit. Now, I think this is a lot of fun. It's a puzzle. You know how like in the puzzles you find the corners and then you find the outsides and things like that? Well, it's the same kind of thing. You take the steps needed to fill in a puzzle. Okay, so step 1. Decide which resistors in a circuit are connected together in simple series or simple parallel. Okay, so simple series or simple parallel. So you find two parts of a wire that are connected simply. So for example, this right here is a simple series circuit. You got two resistors all in one path. Okay? We also have the same thing here. Now we don't have any simple parallel. We don't have any 2 or 3 resistors, individually in parallel. Okay, but we do have 2 simple series circuits. Now we're going to redraw the circuit. We're on step 2 now. We're going to redraw the circuit, replacing each of those series and parallel resistors as if we had one. Okay, so right here with R2 and R3, we're going to pretend that that's just one big circuit. Alright, now if each one has a resistance of 10, and it's series, then it's 10 plus 10 is 20, right? So rather than having R2 and R3, we just have one big resistor. Okay, so the red is our new resistor because they don't really have space to completely redraw it. Okay, and this has 20 ohms of resistance. Now up here, same thing. It's all one big resistor rather than 2 smaller ones. And that's 20 ohms in itself. Okay, so we've withdrawn it. We've made them single resistors. Now, step 3 is repeat step 1 and 2 again. Alright, so I am going to try and redraw this over here just so it's a little bit easier to see. So now we have a resistor here of 20 and a resistor here of 10. Right? 20, 10, and they come down, and it forms 2 paths. This one has 20, this one has 10. Okay. Now, step 1, decide if we have any in simple series or simple parallel. Well, we have no more simple series. But this right here is a very simple parallel, as is this right here. They're both nice, easy, simple parallel. So we'll identify theirs. Now we're going to redraw it as if it was a single resistor. Okay, so those 2 on top become 1. The 2 on the side become 1. And we now have a new circuit. Now the one on top is in parallel. So 1 over 10 plus 1 over 20 equals 1 over Req. So that would be 3 over 20 equals 1 over Req. So 20 over 3 is our resistance. Now the second one has the same resistors, so that's 20 over 3 as well. Okay, step 1 done again, and step 2 is done again. Now let's see, do we need to repeat it? Yes, because we still have 2 more variables. Alright, so simple series. Well, this is a very simple series circuit right there. So we combine them as if they were one. So since they're in series, it's 20 over 3 plus 20 over 3 becomes 40 over 3. And 40 over 3 is the resistance of our circuit, because we've combined them all down to where we just have one overall resistance. Alright, well let's try this one more time. Alright, step 1. Identify anything in simple series or simple parallel. Well, that's this guy right here. Okay? So, if we say they're each 3 ohm resistors, then this resistance right here is 6, because it's in series. Okay? So, step 1, step 2 done. Now, well, step 2 is redraw it. Goes down, he splits off, and comes back, and he's down here. So he's 6, 3, and 3. Alright, step 1 and 2 done. Now step 3, let's repeat. Well, we still have 2 resistors. Well, these 2 right here are a nice, easy parallel. So 1 over 3 plus 1 over 6 equals 1 over REQ. So that works out to be 3 over 6 equals 1 over REQ. So REQ equals 2. So we erase this, because now we can just erase this fun circuit. And rather than having 2 resistors there, we now have 1 resistor with a resistance of 2. Alright, step 1 and 2 are done. Now step 3, let's repeat. We still have more than 1 resistor. So we combine these 2. Now they're in series. So 3 plus 2 equals 5. So the overall resistance of the circuit is 5. Okay? So we're just repeating step 1 and 2 over and over again until we're down to only 1 overall resistance. Alright. Now you each have one on your own version that's a little bit different, so give it a try. And if you need to rewind and rewatch this, good luck.